So that is the housing prices data. And if you look at the top, we have a bunch of variables. House number, does it matter? Is it significant? Do we care if the house number is in our model or not? No, it's useless. It's just there. How about taxes? Would taxes determine the size, the price of your house? Yes. What about the number of bedrooms? Yes. What about the number of bathrooms?
Yes.
What about the footage? In other words, where you live? Or where the house is at? Yes or no?
Yes.
Yes. What about, I don't know what NW is, let's get that. I have to look at the description. That is the price, but move on to the size. Would the size of the house matter in determining the price of the house? Yes. What about the lot size? Would it matter? Yes. So, of all the variables that we have up there, taxes, bedrooms, bathroom, number of bedrooms, number of bathrooms, important, the size, the lot size, they all determine the price of the house. Do we agree? Okay. 1, 2, 3, 4, 5, 6. 6 variables. Are those 6 variables independent or dependent? Before we go there, price. Is that a dependent variable or independent variable? Dependent. So price depends on what? Based on what I just said. Are you talking to yourself? Louder. Julie's is just wondering what you're saying.
It depends on all the qualities of the house.
Okay, which are?
The bathrooms, bedrooms, size, the lot, taxes.
Taxes. Okay. So price depends on size, lot size, important, bathrooms, bedrooms, taxes, all of this. So there are 6 independent variables. There are 6 predictors. We haven't gotten there yet. That is chapter 13. So for now, the example uses only the size of the house and Y is the price. So they've given you the selling price in dollars and the size of the house in square feet. Good. And with the data, we want to come up with a linear regression model. So let's StatCrunch, pretty straightforward. So applets should do it. Say linear model. Regression, start, regression, simple linear, asking for X variable. What is our X variable from the question? The size of the house, so I'm going to think size. What is the Y variable?
Price.
The price, the selling price. The applet will do a simulation or a specific example for you. Here, we don't want to do grouping. It's asking you as to what to do. We are performing a hypothesis test. Yes, specifically, what are we testing for? If you go back to the question, here it's wanting to know whether the slope equals 0 or not. very similar to the example that I just discussed. So in StatCrunch, of the two, we have the first case and the second case, which is confidence intervals. We'll talk about that later. So the first one will test to see if intercept is 0 versus intercept not equal to 0. The second, slope is equal to 0 versus slope not equal to 0. That's good enough. You can ignore the rest and just hit compute. So that is what I get for our fitted model. The model is price is 9,161.16 approximately, plus 77.007 multiplied by the size. Over here, we have the parameter estimates, intercept, slope. That's the standard error right here. And there is the t-score, they call it t-start. The degrees of freedom is 98. The p-value, there is one for the intercept, there is one for the slope. I want you to write that one down. Price equals that expression. And we want to find the standard error. Oh, you can't see? Oh. So the price is equal to 9,161.16 and plus 77 times size of the house. The number of observations in the data set is 100. So there are 100 houses. The t-score for slope is 11.62. And the p-value is listed as less than 0.0001. Good. Okay. Now, the textbook provides a summary, and that's the summary that the book has. The intercept is 9,161. Does it match the value that we put down? The slope that's here is 77. Does it match? The standard error is 6.63. Does that match? Okay. T-score 11.6. Yes. P-value less than 0.0001. Same conclusion. Anyone can come up with these numbers by all means. A software can easily do this. Our objective is to do those 4 parts. First, we want to state the hypothesis, use the test statistic, and come up with a conclusion. So, of interest in this problem is to determine whether the slope parameter is 0 or not. Good. Now, the slope here is 77. And you may say, well, 77 is not equal to 0. Now, that is the purpose of statistics, or the principle of statistics is just because a number is not equal to 0 doesn't mean that it couldn't ever be equal to 0. In this problem, though, I know from experience that we will be rejecting the null. You should also know by now, if you connect the dots and look back at or think of what we did with the chi-square test. When we rejected the null, we looked at the p-value, and if the p-value is less than alpha, we rejected the null. What is a typical value for alpha? 0.05. What does it say in the summary? It is less than 0.0001. Clearly, it is less than alpha, so we will be rejecting the null. If we rejected the null, we are concluding that the price of the house is linearly related to the size of the house. Yes, so that is our conclusion. In practice, any number, any p-value that goes below 0.0001, we'll just write it as that. Every software, most of them will do the exact same thing. I'll show this in SPSS as well next time. But it is not actually 0.0001. There is an exact scientific number. When we come back next time, we are going to make use of the standard error and the value of the estimate to come up with a t-statistic using your calculator, and we will come up with the p-value and the critical value test.